ngasigi class na kinematics ki class ni ko se koi na se motion dagi race kana be ai ko a body is said to be in motion if its position changes with time, and a body is said to be in rest if its position does not change with time. Matam gi matu ina my position hongdragadi akona rest kawi matam gi matu ina magi position change toragadi akona body du motion de level kawi motion jeta akona different say part tona khairo payai say for example uniform motion, uniformly accelerated motion maroina. So uniform motion haitadi kaino haitadi the motion of a body is said to be uniform if it describes equal distance in equal time. If the body describe equal distance in equal interval of time, then the body is said to be in uniform motion. Now for uniform motion, the distance travel in time t is s equal to vt, where v is known as velocity, and velocity also we can define as rate of change of displacement. And this is in differential form, it is given by dr by dt. So velocity we can write as dr by dt, means first derivative of displacement with respect to time. Kona uniform motion gidi, for a body moving with uniform motion, distance is equal to velocity into time. Now so we can find out different problems, like say here is a slab glass, so this is a slab glass. Now a ray of light enter to this, it pass to this. Then suppose if the thickness of the glass slab is say 10 centimeter, if the thickness is 10 centimeter, so the question is what is the time taken by light to pass through the glass slab. What is the time taken by light to pass through the glass slab? Now here velocity of light in the glass slab is velocity of light divided by refractive index. So this is 3 into 10 power 8 divided by, say for example, refractive index of glass slab is 1.5. So what is 1.5? So 2 into 10 power 8 meter per second. This is the velocity of light in the glass slab. So time taken, time t equal to, say, distance divided by velocity. So distance is 10 centimeter. Now convert in meter, divided by 2 into 10 to the power 8. So this is 5 into 10 power minus 10 second. Now we can go to uniformly accelerated motion. An equation for uniformly accelerated motion. So let me write. Uniformly accelerated motion. So we can define acceleration. Acceleration is rate of change of velocity. So acceleration is defined as the rate of change of velocity. So acceleration A equal to, acceleration is vector, so we can write as dv by dt, or we can put as d by dt of dr by dt. So this we can put in as second derivative d2r by dt2. So acceleration we can express like this: second derivative of position vector or displacement, second derivative of displacement. Now we can discuss the equations of motion for uniformly accelerated motion. Okay. Now uniformly accelerated motion. For uniformly accelerated motion, the equations of motion are: number 1, v equal to u plus at, where v is final velocity, u is initial velocity, a is the acceleration, t is the time. Say for example, a body start from this point A. After some instant of time, the body is at B. So the velocity when the body is at A, or the velocity of the body at time t equal to 0. The moment we start counting time is known as initial velocity. And the velocity after time t is v. Then the equation is this, b equal to u plus at. And we know that v square equal to u square plus twice as, where s is the distance. Also we know that s equal to ut plus half at square, and s nth, this distance travel in nth second, is u plus half twice n minus 1 into a, where a is acceleration, and s is distance, t is time taken, u is initial velocity, and v is final velocity, and s nth is distance travel in nth second, like 5th second, 6th second, 10th second, like that. So we have this 4 relation. Now we can go to equations of motion for a freely falling bodies. So suppose this is the ground, a body is dropped from this point, so here the velocity at this point is u, and the velocity with which the body strikes the ground is v. So h is the height from which the body is dropped, and t is the time taken by the body to reach the ground. Now for this we have the relation v equal to u plus gt. Number 2, v square equal to u square plus twice gh, where h is the height, and number 3, h equal to ut plus half gt square, and h nth equal to u plus half twice n minus 1 into g. Now this is for falling bodies. For bodies which are projected vertically upward, so for example, this is the ground, a body is projected vertically upward with initial velocity u, and the velocity with which it reached the maximum height For this case is 0. So the relation is number 1, v equal to u minus gt, because the body is moving upward, particularly upward, so g is taken as negative. And number 2, v square equal to u square minus 2gh. Number 3, h equal to ut minus half gt square. And h net equal to u minus half twice n minus 1 into g. Now we come to the average velocity and average speed. So average speed is total distance divided by total time, and average velocity is total displacement by total time. Now average speed is a scalar quantity, while average velocity is a vector quantity. Now we can consider different cases of average speed and average velocity. So average speed and velocity for body traveling distance in time t1 and t2. Distance in time t1 and t1 to t2. So, for example, the body travel, say here time t1, so time t2, so average speed equal to total distance is s, if s is the distance, divided by time interval is t2 minus t1. So average speed equal to this, and average velocity is same because they are moving in the same direction. Not we can, for straight line motion average velocity is equal to average speed. Now in this case, this average velocity for bodies traveling distances s1, s2, s3 and so on, sn etc. with velocities v1, v2, v3 and up to vn. So suppose this is a straight line. So suppose this is s1 and the body moves with velocity v1, and this s2 and the body moves with velocity v2, and s3 the body moves with velocity v3 and so on. Now average speed is equal to total distance divided by total time. So total distance is s1 plus s2 plus s3 plus sn, and total time is t1 plus t2 plus t3 plus tn. So this s1 plus s2 plus s3 plus sn divided by t1 is s1 by v1 plus s2 by v2 plus s3 by v3 plus sn by vn. So this is average velocity. Now the body travel equal distance with velocities v1 and v2. Equal distance. Suppose a body moves from A to B. Distance between AB is s. Now s by 2. For the half distance, the body moves with velocity v1, and for the another half distance, the body moves with velocity v2. Now for this average speed or velocity, because it is a straight line motion, is equal to total distance is s by 2 plus s by 2 divided by total time is t1 plus t2. So s by 2 plus s by 2 is s divided by t1 is s by 2 divided by v1 plus s by 2 divided by v2 . So this is s divided by s by 2, 1 by v1 plus 1 by v2 equal to s cancel. So 1 divided by half v1 plus v2 divided by v1 v2, or this we can put as twice v1 v2 divided by v1 plus v2. So v average. Now the average velocity for bodies moving with velocities v1 and v2 in equal intervals of time. So the body start from this point A. Suppose in time t1 equal to t by 2. If time taken by the body to travel from A to B is t, then for the half distance, half time, the body moves with velocity v1, and the remaining half time t2 is t by 2. Half of the time the body moves with velocity v2. Haidi suppose AO dagine O box se mana sakadruba matam dugi tangkhai de chale so the and aduga mana chatpa velocity na v1 and remaining half of the times here with velocity v2 galona chali adu tadi v average is so distance of AO plus distance of OB divided by T1 plus T2. So distance of AO is say B1 into T by 2 plus B2 into T by 2 divided by T by 2 plus T by 2. So this after cancelling T we get half V1 plus V2. So V average. So this is the average velocity. Now come to relative motion. So relative motion, what do you mean by relative motion? Relative motion is important kanoni. Or we call relative velocity. Relative velocity. Motion with related with some observers, relative motion, and velocity of a body is observed by some body, or the velocity of a body is seen by some observers is known as relative velocity. Siam important ni sitagi akoina Doppler effect adagi atopa special theory of relativity gaina to Albert Einstein in 1905 the special theory of relativity ihanana putoi aduna according to Albert Einstein motion khudema relative way say what so say suppose is say ahan naha haibasiba relative waramni I am old is compared to my young friends. I am young as compared to my old friends. I don't know old young haibasiba relative waramni aduna now relative velocity she say kona a body A, so suppose a body A is moving along this with velocity VA, and another body B is moving along this with velocity VB. So the velocity of A with respect to B is known as relative velocity of A with respect to B. So relative velocity of A with respect to B is equal to relative velocity velocity of A minus velocity of B. Now relative velocity of bodies moving on parallel tracks. Suppose here A is moving along this with velocity VA, another body B is moving along this with velocity BB. Then relative velocity of A with respect to B is equal to BA minus BB. If the two bodies are moving in the same in a parallel tracks in the same direction, then the relative velocity is BA minus BB. Now, next case is when body A and body B are moving in the same directions with same velocity. Say for example A, B, A is moving with velocity BA is and B is moving with same velocity, then relative velocity of A with respect to B is BAB equal to BA minus BB equal to B minus B, because the magnitude of velocities are same, so the relative velocity becomes 0. Asa kaiguma body any same direction with same velocity salagadi on parallel tracks, their relative velocities will be 0. Now suppose body A and body B A is moving with velocity BA and B is moving with velocity BB. So in this case, relative velocity of A with respect to B is BAB is equal to BA minus BB. So BA plus BB, BAB. So relative velocity becomes added. And opposite direction the body need to move talk tagadi. Relative velocity do tangent nani. Aduga same direction the parallel tracks same direction salagana relative velocity kaidong nani. Say I example lama pige. Say a bus is moving along this with velocity of the bus is say 60 km per hour. So this is a ground the velocity of ground is A. So relative velocity of ground with respect to the bus, that is VAB equal to VA minus BB equal to equal to 0 minus 60 equal to minus 60 km per hour. And a bus manunga tonga a bus ki tongnau de yangokanda tongnau dagi uber uero yum moiro. See, they appear to move in the backward direction. Kaigino haita the relative velocity of the ground or relative velocity of the house with respect to the bus is negative. Aduna never kona maning lom the winner. Some sat kiboina uris. Now come to projectile. So what is a projectile? Projectile height adi kaino height adi any body or particle given some initial velocity, and moves freely in the space under the influence of gravity alone. So akona projectile as you know body amanda ko some velocity impart tore adu velocity because of the velocity aduna body to move tore under the influence of gravity alone adu body adu projectile ko aro projectile is kam important way anga ama hek pokpadagi na chahi ama ni surukpadagi mana pot ama pairaga langba hairakpa adudagi ma projectile level si associate tore mana glass ama ball ama pair lange ball du projectile kawi koina nauri kape nauri dugi maru du bu projectile kawi nomai kape nomai maru du kadawi we impart some velocity and the body moves with that velocity with that initial velocity in space under the influence of gravity alone aduna projectile is body dubuni and trajectory is a kind of height part of the projectile is called trajectory. So gonna see the body lang and the body moves along this. So the path is known as trajectory and it is parabola. Now there are two assumptions in this kind of the air. Number one, air resistance is negligible, and number two, so acceleration due to gravity G remains constant. We make these two assumptions while studying the case of projectile. Number one, air resistance is negligible, and number two, acceleration due to gravity G remains constant. Ani assumption ani sitawi. Now projectile projected horizontally from a height with a velocity u. Suppose this is the ground, and the projectile is projected from some heights from the ground. The projectile is projected with initial velocity u, and the projectile moves like this. Now so projectile is projected with initial velocity u. So now what is the component of velocity? We can consider into, so we can resolve velocity into two components. Say vertical component, and vertical component of velocity means Vy equal to 0. Horizontal component of velocity is u. So we can say initial vertical component, initial horizontal component, and the vertical component of acceleration due to gravity, say ax, ay, we write ay equal to g, and ax equal to 0. Horizontal component of acceleration due to gravity is 0. Now say horizontal motion, vertical motion. Now P be a point of the projectile at any instant of time t, and the coordinates of the point P is x, y. So now what is x? X equal to ux plus ax t. So this ut. X equal to uxt plus half axt square. So this is ut. So this is question 1. Next. And for the vertical motion, say y equal to uyt plus half ayt square. So this is half ay is g t square. Now from equation 1, g is, what is t? T is x by u whole square, hence y is equal to g by twice u square into x square. This is equation of a parabola. Hence the part of the projectile is parabola. Now what is time of flight? Now we know that u equal to uyt plus half gt square. For this y is height, because the height of the projectile is height, so half g t square, or t equal to root over 2h by g. So this is time of flight of the projectile. Then horizontal range of the projectile. Horizontal range is horizontal distance. Horizontal distance covered by the projectile. So this is from the foot of the tower to the point where the projectile hits the ground. So horizontal range is x equal to u x into t, or heights we can denote it by r. Horizontal range, r is u, t is root over 2h by g. So horizontal range is this. Now resultant velocity at an instant of time. So here dx equal to initial velocity plus axt, so equal to u, and Vy equal to initial velocity along vertical direction plus Ayt. So this is Gt. Now resultant velocity magnitude is, so v square equal to ux square plus vy square. V square equal to vx square plus vy square. So this is u square plus g square t square. So this v. So this is the velocity of the projectile at an instant of time. Then Then velocity of the projectile when it hits the ground. So velocity with which the projectile hits the ground is v equal to bx square plus by square. So this is u square plus by is gt, or g, instead of t we can write like this, 2h by g, or 2h g square by g, or 2gh. So instead of b square we can put as 2gh. So this is a velocity with which the projectile hits the ground. Now the second case is projectile projected at angle theta with the horizontal. So now we consider a projectile projected with initial velocity u making an angle theta with the horizontal. So the projectile moves along this. So AB, so this is known as maximum height, vertical height, and this is horizontal range. The vertical height, and time taken by the projectile is known as whole time of flight. Now the use we resolve into two components. Say ux means horizontal component of u, so this u cos theta. Say uy is u sin theta. Now horizontal motion, the vertical motion. So for horizontal motion, velocity bx equal to ux plus axt. So this is u cos theta. So this is equation 1. And for vertical motion we have vy equal to uy plus ayt, or vy equal to ay is u sin theta minus gt. So this is equation 2. y minus because ay. So direction of acceleration due to gravity along y-axis is negative. Now distance travel. So x equal to ux t plus half ax t square equal to ux is u cos theta into t. So this equation 3x. And distance travel along y-axis is, say, y equal to uyt plus half ayt square. Now this u sin theta into t minus half g t square. Now put t equal to x by u cos theta from equation 3. So this y equal to u sin theta into x divided by u cos theta minus half g t square, means x square by u square cos square theta. So y is u cancel, so x tan theta minus half g 1 by u square cos square theta, or g divided by twice u square cos square theta into x square. This is equation of a parabola. So the part of the projectile is parabola. So this is known as equation of motion. Now maximum height h. Now b say by square equal to uy square minus 2gh, or at maximum height velocity is 0, so u square sine square theta minus 2gh, therefore h is equal to u square sine square theta divided by 2g. So this is the maximum height of the projectile. Time of flight t. So time of rise equal to time of fall. So Vy equal to Uy minus Gt. So this 0 equal to U sine theta minus Gt. Therefore t equal to u sin theta divided by g. Then whole time of flight t equal to twice t equal to twice u sin theta divided by g. The horizontal range R is equal to ux into whole time of flight equal to ux is u cos theta, and whole time of flight is twice u sin theta by g. So this is u square sin 2 theta by g. Now for maximum horizontal range, so sin 2 theta is equal to 1, so twice theta equal to pi by 2, or theta equal to pi by 4 equal to 45 degree. Now maximum horizontal range phangya tadi angle of projection should be 45 degree. Now two angles of projection for same horizontal range. Jadi aku na say R1 equal to u square sin 2 theta 1 by g, and R2 equal to u square sin 2 theta 2 by g ne. Halo aku na so horizontal range will be same for angle of projections theta and 90 minus theta. Horizontal same horizontal range phangni. Now velocity of the projectile at any time t. Now so v equal to vx square plus vy square. Now vx is u square cos square theta plus uy is vy is u sin theta minus gt whole square. So this is u square cos square theta plus u square sin square theta plus g square t square plus twice u gt sin theta. So u square plus g square t square plus minus it will be minus twice so minus twice u g t sin theta. Now come to uniformly circular motion. So we consider a circular path. A body is moving with initial with velocity v, and the radius of the circle is r. Then angular velocity so angular velocity is angular displacement divided by time. So angular velocity is denoted by omega. Omega is theta by t, or theta equal to omega t. Time period is time taken to make a complete rotation. Then what is the relation between time period and angular velocity? So relation is angular velocity omega equal to 2 pi by t. And frequency is number of rotation in 1 second. And angular frequency is reciprocal of time period, that is nu equal to 1 by t, or time period is equal to 1 by nu. Now relation between angular velocity, time period and frequency. So angular velocity equal to 2 pi by t equal to 2 pi frequency. Omega equal to 2 pi frequency, or 2 pi by time period. So what is the relation between linear velocity and angular velocity? So angular velocity omega is equal to 2 pi by t, or 2 pi. What is total time? Total time is circumference divided by velocity, because the body is moving with velocity v. So this is v divided by r. So v equal to r omega. Now centripetal acceleration. So O is the center of the circle, R is the radius, and this P. Here radius vector R equal to x I plus yj. Or this what is x? If this angle is theta, x is r cos theta I plus r sin theta j. Now this velocity v is dr by dt equal to minus r so this is d by dt r cos omega t I plus r sin omega t j. So r so minus omega sin omega t I plus omega cos omega t j. Then magnitude of velocity. So v equal to root over say minus r omega sin omega t whole square plus r omega cos omega t whole square. So this r square omega square sin square omega t plus cos square omega t. So this is r omega. So v equal to r omega. Now acceleration a equal to dv by dt equal to d by dt of r omega minus sin omega t I plus cos omega t j. So r omega, now differentiate this, minus cos omega t minus omega cos omega t I minus omega sin omega t j, or minus omega square r cos omega t I plus sin omega t j. So this A, then magnitude of acceleration, we call centripetal acceleration, A equal to minus omega square r. Hence so A equal to magnitude means this will be plus, so r square omega square r, or we can put as b square by r. So this is known as centripetal acceleration.